Welcome to an introduction to educational research. Pardon me, today's video is dealing with hypothesis and hypothesis testing, which is the basis of all experimental research. So let's take a look what we have here. Okay, now a hypothesis is a researcher's tentative prediction of the results of the research findings. And this is a direct quote from Gay and Arison. And these are the resources that we've used for the video. And a hypothesis states the researcher's prediction. This is what the researcher is predicting about the relationship among variables that are under study. So it's a prediction. And it's not unusual for a research study to have many variables, and so there may be more than one hypothesis. And it's important to keep in mind that research doesn't prove anything, and a researcher does not attempt to prove the validity of a hypothesis. Rather, they're collecting data to make a decision as to whether to support or not support the hypothesis, but we'll get into more on this later. But we have, the big picture, we have theory and we have the literature out there, different research literature. And from reading the research literature and studying theories, researchers then formulate certain questions or hypotheses, and they create studies, and then based on the results of that studies, they either confirm or reject or support or not support the hypothesis. So that's how experimental research works. So let's take a look here. Characteristics of a good hypothesis. It should be based on sound reason. It should follow from previous theory, and it also should lead to future theory. And by rejecting or accepting the hypothesis, this will contribute to educational theory. That's the idea. The second characteristic, it provides reasonable explanations for predicted outcomes. So the explanations need to be reasonable, not outlandish. So your telephone is not working and you call the phone company and say, well, there are butterflies on my phone line and that's why the phone is not working properly. Well, that's not a reasonable explanation. So hypotheses supply reasonable explanations. They clearly and concisely indicate relationships between operationally defined variables. So they clearly indicate the relationships between variables that are operationally defined, very clearly and specifically defined. And last, they can be conducted in a reasonable length of time. These are the four main characteristics of good hypotheses. Now, there are several different kinds of hypotheses, and it's not critical that you remember all of this, but you just should have a big picture, an idea. There are inductive hypotheses, which tend to be associated with the qualitative research methodologies based on a bunch of observations, specific observations that are going on. And then all of a sudden, out of all of these different observational data collected, certain patterns seem to develop. And certain patterns and relationships seem to bubble up and they look interesting. And therefore, hypotheses are then generated. And this is an inductive process from the bottom up, whereas the deductive process works from the top down. So theory sort of indicates and predicts certain things should happen, and so researchers then conduct hypotheses based on theory and then see if these predictions are correct. But generally in educational research, we have the research hypothesis, or actually it's referred to also as an alternative hypothesis, that states an expected outcome, and that's what hypotheses do. They predict expected outcomes between variables under study. And in terms of research hypotheses, they can be non-directional or directional, and a non-directional states a relationship, but it doesn't indicate any direction in that relationship. So here's an example. There will be a difference in math test scores of fourth grade students who are instructed using computer-assisted instruction and those who receive regular instruction. So this hypothesis is non-directional. It's saying there'll be a difference, but it's not indicating whether the difference will be an increase or a decrease in scores or whatever it is they're measuring. On the other hand, a directional hypothesis. Here's an example. Fourth grade math students who are instructed using computer-assisted instruction achieve at a higher level than those who receive regular math instruction. So here there is a direction. They're talking about there'll be an increase in achievement, an increase. The reason that there is these two types of hypothesis, directional and non-directional, has to do with how statistically they are analyzed. And this is not a course in statistics, so we don't need to go into one-tail or two-tailed tests. But just be aware that there are, in terms of the research hypothesis, there are two types, non-directional and directional. And when you're reading a research article, you would want to be aware of what kind of research hypothesis is this. Is it directional or non-directional? Now, the third type of hypothesis, which is not a research hypothesis, it's referred to as the null hypothesis, the null hypothesis. And this is the hypothesis of no difference. So the null hypothesis states there'll be no difference between the relationship between variables no matter what happens. So an example of what we were just looking at is there is no significant difference in the achievement of fourth grade math students who are instructed using computer-assisted instruction and those who receive traditional instruction. So the null hypothesis actually is very important because it is the basis of hypothesis testing. And we'll explain that in a minute. But let me just say this. When you're reading a piece of research, the researcher will state the research hypothesis. It'll be something like the purpose of this research is to yada, 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 yada. And it'll be stated in either a directional or a non-directional or directional form. The null hypothesis is never stated in a research article. You won't find them referring to a null hypothesis or a hypothesis of no difference. But when statistically the data is analyzed, it is analyzed based on will the researcher accept or reject the hypothesis of no difference. And I will explain that, hopefully, in the next couple of screens. We're going to use a research article. And if those of you are in my class, you've probably already read this article, Prompting Bar Patrons with Signs to Take Free Condoms. And this is the citation. And this is the abstract to that article. So let me read it to you. The type is not that good. This study was designed to determine whether signs would prompt bar patrons to avail themselves of free condoms. The intervention at 3 gay bars involved placing a large sign directly above a container of free condoms. The sign gave statistics for the number of people who have died from AIDS in the state and pointed out that condoms can reduce the spread of AIDS. Additional signs placed in the restrooms gave information about safe sex practices and reminded patrons that free condoms could be obtained at a given location at the bar. An ABA design was used with a 2-week baseline, a 2-week treatment with signs present, a 2-week reversal or withdrawal with no signs present, and a 2-week reinstatement of treatment with signs present. For all 3 bars combined, 748 condoms were taken with signs present, and 510 condoms were taken with signs absent. Overall, the signs were present. Overall, when signs were present, the number of condoms taken increased by 47%. Okay, so that's the abstract. Now notice the first sentence says this study was designed to determine whether signs would prompt bar patrons to avail themselves of free condoms. So that's the research hypothesis. So, and I kind of think this is probably directional because they're saying the study was designed to determine whether they would prompt bar patrons to avail themselves, but it doesn't really talk about increasing. But I think they're implying that. So this is probably a research hypothesis that may be directional. Now let's go to the next screen and take a look at what happens. Again, this is the article. So the results section, this is the results section of the research article. And the interesting thing about this is most of the time we skip over this because we really don't quite know how to read it. So I'm going to try and go over it and sort of hopefully demystify it a little bit. So the results section of the research article is shown in the red box. The research hypothesis, or the alternative hypothesis, most likely is that prompting bar patrons with signs to take free condoms will increase the amount of free condoms taken. So that's the research hypothesis, or the alternative hypothesis. The hypothesis that is not stated in the article and on which the statistical analysis of the results will be done is the null hypothesis. And this is that the amount of condoms taken will neither increase or decrease whether signs are present or not, that there'll be no difference. Now here is the results section. And I'll read this to you because it's sort of wacky, but say data from the 3 bars are displayed in figure 1. We don't have access to the figure 1, but this is what figure 1 looked like. Results were statistically analyzed by comparing 2 time periods when signs were present with the 2 time periods when the signs were absent. Remember, they introduced signs, then they withdrew them, and then they introduced them and withdrew them. Actually, I think they did it in the other order, but you get the idea. In bar A, 275 condoms were taken with signs present, and 139 condoms were taken with signs absent. The statistical test they used is chi-square. This is the Greek letter chi. Chi-square, and this stands for degrees of freedom, equals, and this is the chi-square test score, 44.6. The probability is less than 0.001. And you can see that over here in bar A. When signs were present, 275, no signs, 139. The statistic was a chi-square, which is an appropriate statistic for this kind of data. With 1 degree of freedom, this is a statistical thing we won't get into. We don't need to know about that to interpret the results. The chi-square score was 44.6, and we get a probability level of less than 0.001. Now in bar B, 246 condoms were taken with signs present. 228 condoms were taken with signs absent. They did a chi-square test with 1 degree of freedom. The chi-square score was 0.68 and NS. And that's right here. This is bar B, right there. In bar C, 227 condoms were taken with signs present, and 143 condoms were taken with signs absent. They did a chi-square test again with 1 degree of freedom. The chi-square score was 19.1, and the probability was less than 0.001. And that is bar C right here. That's the results. And then, with data from all bars combined, 748 condoms were taken with signs present, and 510 condoms were taken with signs absent. Chi-square with 1 degree of freedom, the score was 22.5, and the probability was less than 0.001. For all bars combined, the signs resulted in a 47% increase in the number of condoms taken. Well, that is a mouthful, and what does it mean? I mean, just how do we go about interpreting that? Well, we can see when signs were present, there seemed to be more condoms taken, but is that statistically significant? Does that mean anything? Well, here is how we interpret this data. The chi-square test is a statistical test that exists in the black box of statistics. We don't need to know what's in that black box. There are all kinds of ugly formulas and things like that. If we were taking a statistics course, we would need to, but we don't here. We just need to how to interpret the results. So we don't have to pay any attention to this chi-square test, or the degrees of freedom, or even the chi-square score. It's not important to us. And by the way, this in bar B, the NS means that the results were not statistically significant in bar B. So we don't have to pay attention to any of this. The only thing we need to pay attention to is the probability score, and we need to know how to interpret that. Just what does that mean? Well, first of all, if you're a little rusty on your decimals, 0.001 is a decimal fraction which is equal to 1 out of 1,000. 1 out of 1,000. So the probability here on the chi-square test is less than 0.001. So it's less than 1 in 1,000. The same for bar C and the same for the total data. Well, what this means is the p-value indicates the probability that the null hypothesis is true. Now remember, in this case, the null hypothesis was the hypothesis of no difference. Whether there were signs or not, there would be no difference in the amount of condoms taken. Well, according to our chi-square statistic, the null hypothesis will be true 1 time out of 1,000. 999 times the null hypothesis will be false. We would reject the null hypothesis, and therefore we would accept the alternative or the research hypothesis that we can say with a high degree of probability, very high degree, less than 1 in 1,000, or that it was the independent variable or the signs that caused the increase in the amount of condoms taken. So that's how you interpret that. If you look at bar B, bar B was not significant, but in bar C, the results are exactly the same. The null hypothesis, the hypothesis of no difference, will be true 1 time out of 1,000, actually less than 1 time out of 1,000. So 999 times out of 1,000 we can say with a high degree of probability that it was the independent variable. It was the signs that resulted in the increase in condoms. And the same in the overall data. It's exactly the same thing. The chances of the null hypothesis being true is less than 1 in 1,000. So that's how you interpret this probability figure. Now, in educational research, we generally will reject the null hypothesis and accept the research hypothesis if the p-value is 5, this is 5/100ths or less. 5/100ths or less. So anything greater than 0.05, we would accept the null hypothesis. There's too much chance involved, so we will accept the hypothesis of no difference. But if it is 0.05 or less, and this would be 0.05 means that 5 times out of 100 the null hypothesis would be true. Well, that's 95 out of 100 the null hypothesis is false, and we would reject it. So we would reject it. But if it's greater than 0.05, like if it were 0.06 or 0.08 or 0.12, that's all greater than 0.05, we would then accept the null hypothesis of no difference, and we would reject the research hypothesis. Well, that's hypothesis testing 101. I hope I didn't confuse you too much. But let's give you a little assignment and see what you can do. So if you would create a Word document titled your name _ hypothesis testing, and then respond to these 2 scenarios below. A study was conducted to examine the effects of scripted lesson delivery versus traditional lesson delivery on the language arts performance of 8th grade students. The experimental group received language arts instruction via scripted lessons, and the control group received traditional lesson delivery. At the end of the 8-week study, students were tested and group mean scores were analyzed. A t-test, which would be appropriate, of group means was performed to compare the two group scores. The results were the t statistic with 2 degrees of freedom, and the t-score was 34.5, probability less than 0.03. That's 3 in 100. What was the research hypothesis? What would be the null hypothesis in this research? And based on the data, would you accept or reject the null? And please be specific in explaining why. And then the second scenario is very similar, and you're to do the same thing. What would be the research hypothesis, the null hypothesis, and based on the data, would you accept or reject? And please explain. Well, okay, that's it. Thank you very much for your time. Here are the resources used. And again, we will see you next time.